Right. Hello, my name is Cole Wilson,
And I'm Shane Gans.
and this is our game Uno.
We're going to be doing a demo here. This is demonstrating the networking. This can work on two different machines, but here we're just demoing it on one for screen recording purposes.
And it can work up to about 10 machines as well.
So here I'm going to designate this one as the host. And so there's a unique code for it. And then this one here, I'm going to be joining. And I will be typing in the code here. And then it's going to wait for the host until the host is ready. And the host is going to hit enter. And then the host joins, and then right after the first player joins. Yeah, go on.
Yeah, the host gets to pick a card. So right now there's nothing they can play, so they're going to draw a card by clicking the draw pile.
So there I actually hit D because you can hit the on the keyboard D or click on the draw pile. Yeah. So then it's
and then you get to draw again because you can have a card. And now it's player two's turn.
And here there's mouse support as well. And then here's an example of the wildcard function, which will let you choose the color that it is. So like here we choose green, red, green. And it'll show up on the card itself as what it was chosen as. And there's other special cards like skip, which in two-player won't actually do anything.
Same with reverse.
Same with reverse, but they do function. You can actually see which direction it's going on these arrows here, as well as the cards in the hand of each player. But yeah, it's Uno from now on. Basically, you can just go between the two here. But this works for up to how many do you say?
Up to about 10 players. You start to run out of cards.
Yeah, there could be more cards added per players, but this is just the solution we have right now.
Yeah.
And yeah, that would go until eventually there's a winner. It would let everyone know.
Yeah. And it says Uno when you're down to one card, etc.
And there's some sounds, as you probably heard.
Yeah.
So yeah, we're gonna go through the code now. We do have main here, and there are some test cases that are in another solution here, but this is where they would be.
Yeah. So we have 5 test cases. We won't show them right now, but we have a lot to go through. But the main thread is the graphics main, which is a thread called graphics main, and that's where we run all of the SFML graphics. So you can see here in the header, it has a lot of it has the sound files, it has the different textures and sprites that we're using in the fonts. And then in the main run file, it's just a event loop and a render loop that shows all of the different components like the menu and then the actual game.
And then there's also, it links to the thread of the game thread in order to separate the graphics from some of the game logic to keep the server from timing out. Basically.
Right, because the sockets used for the game thread are blocking, so they block the main thread, but we need the event loop to keep running, to keep the window open, and to make it keep responding to user input. So we separate that into a different thread, which we'll get to more later.
And so this is for the main menu of like hosting and joining. And so there's the different states that it can be. You can be just on the main menu. You can have chosen host. You can have chosen join, and you can be waiting as the joiner, waiting for the host to start. Right. This like sets the default. There's like the constructors. These are the different ways you can move your cursor. This like returns what menu item you chose.
Yeah, and there's just a lot of functionality. Like it also includes the ability to type in a code and display that.
Yeah, that's upgraded. That's updated through the draw.
Store. Yeah.
And then here is where it would. This is where it stores kind of the objects for like the host message that it gets from the server.
Yeah,
as well as the text display and some like textures and stuff for the logo.
Okay, so in game.h, this is where the main game logic is. In graphics, that's all like the SFML drawing stuff on the screen, and the game class is where the actual Uno logic happens. So this is it's a friend of the graphics main class, which means that it can share. It's used to basically share state between them. So it contains a bunch of different objects like different decks for the draw pile, discard pile, hand, and then kind of just game state such as whose turn it is, number of players, what direction you're going, what card you have selected. And then the main thread that's run is this main loop thread, which that's where it's a constant loop, and it waits for turn data from the server, updates the status of the game, and then sends it back to the server.
This deck, this is the main object that we use for like the draw pile, the discard pile, as well as the hands. It uses a deck standard
Standard template library.
standard template library.
It basically just wraps it in kind of easy to understand methods. Like instead of using push front and push back, you can do draw one card, read one card, put one card, etc. And then yeah, it contains a deck of cards, which will
the card object enumerates like the card color and the card type. And so this is like the parent class for both action card and number card.
Yeah. And this is an example of polymorphism because we have a virtual two-string function, which because every card has a color and every card has a string representation to send to the server. But then the actual implementation of this is different between number card and action card.
So here's a action card. This has the different kinds of action cards. And here is where the to string, the void function gets overridden. Yeah. And same for number card, basically. It just has a number and as an int rather than like an enumeration. But yeah, pretty similar. There's another two string, the getters, and same stuff.
Yeah. Okay, and then so in server.h, this is where all the communication and sockets with the server happens. So as I mentioned before, it causes the main thread to block, so that's why we put it in a separate thread. And we use mutexes, locks, and condition variables to basically wait for data to pass between the threads and to synchronize thread safe communication between them. So there's a couple different methods like new game, which sends the like new game message to the server and gets back a code. There is start game, which is like when you're ready to start once all the players have joined, and join game, which is when you're trying to join a game with a code. And then there's like getters for your player ID, the join code, etc. And then later, if you look in the README, there is a UML diagram basically showing the sequence diagram of how all the communication works. And then here we're at this is no longer running on the host computer. This main.py is running on a caprover instance hosted in the cloud in a Docker image. And it basically is the server that all the clients connect to. So essentially it has two functions. It serves as a web server to at uno.cole.ws, and it just basically serves like kind of an info page. And then it also down below, it overrides the Python's built-in TCP handler to handle incoming TCP requests. So every request it gets starts with a join code, and it categorizes each client that's currently connected to it based on the join code. So every message that it gets from a client, it sends out, it basically echoes it out to all the other clients. And that's how communication can work. And we use this instead of a peer-to-peer network because peer-to-peer gets very complicated when you have more than two devices. And then we also wanted to have this work on our university's firewall.
All right, I think that about covers it. We do have a lot more information, as he mentioned, in the README here about like how to run it, and also diagrams about the server.
Yeah, and you can find all this at uno.cole.ws along with a link to download and play yourself.
All right, thank you.